So what we were going to start off with is just a quick explanation of Brighton and Hove City Council's approach to SuDS and adaptation more generally, and then I'll pass over to Paula to talk about the nitty-gritty details of what we did on a particular project. Brighton and Hove commissioned a climate risk and vulnerability assessment and adaptation action plan a couple of years ago, and the main climate change risks for our city are particularly flood risk and surface flooding. So we're ranked eighth flood risk area in England, and over 30,000 properties in the city at risk of flooding. And that surface water from heavy rainfall is what poses the biggest problem. And you can see a little graph down on the bottom there that shows it's particularly our winter rainfall that looks like it's going to be increasing. We'll get to the next slide. So I also wanted to just briefly touch on the carbon kind of perspective for SuDS as well. So PAS 2080 is a publicly available specification for carbon management in buildings and infrastructure. So it looks at the whole life carbon implications of the work that we do when we commission projects and so on. And it requires us to look holistically at the whole life carbon implications of providing resilience to climate change, or not having provided it and needing to do repairs and recovery later. And also, encourages us to seek to use nature-based solutions instead of hard engineering where possible. And I've just got a little diagram to talk through that as well on the next slide. But meanwhile, just to point out that, SuDS reduce flood risk, enhance biodiversity, can increase greening. They can also help to reduce overheating, all of these things that have already been touched on in the previous presentations. And they're often a much lower embodied carbon solution than doing nothing and having to repair damage, and a lower carbon solution than the kind of traditional hard engineering. So putting in bigger drains, building barriers, raising thresholds, and so on. Okay, so this diagram is showing a sort of carbon emitted over time for a drainage system. And so this is our time axis here, and then this is the cumulative carbon emitted. So if you consider we have an area which is prone to surface flooding, and we would have this black line might be what would happen in a traditional engineered system. So we put in some bigger drains. So there is embodied carbon emissions associated with constructing that solution. And then over time, we have to do some maintenance. And so there's some increased carbon emissions there. Then we have a particularly heavy rainfall event. The resilient flood defences do what they're meant to do, but maybe there's a little bit of repair or additional maintenance that needs to happen. So a little bit more emission. And then we carry on over time. So that's your traditional solution. We could also not put such resilient flood defences, ones that are not coping with the future effects of climate change. So we might still build whatever we're building, might have to maintain it, but then when there is a flood, there's a lot more carbon that needs to be emitted in repairing it, and then we continue over time. Whereas if we have a SuDS solution, probably there's a lot less carbon emitted in the construction compared to hard engineering. Over time, because we have plants growing there, may have previously been an impermeable surface, we may even get a small amount of carbon sequestration. And if the SuDS is doing its job, again, there's not a huge lot of repair and damage that needs to happen after the flood event. So that's the kind of the holistic picture and sort of my thinking on how climate change mitigation is linked to climate change adaptation, and how we can take a holistic view and not throw a whole lot of carbon at making ourselves more resilient to the fact that we're using a whole lot of carbon. And nature-based solutions is a good way around that. So I'll hand over to Paula now.
So I'll be talking about a project that we did in Brighton, and you can see this is suburban Brighton. So this area is the South Downs National Park, and oops, sorry. Yeah, so this is the South Downs National Park, and this is where the pilot was. It is a suburban part of Brighton, very low rise, low density, lots and lots of green grass, verges. We are on it's a dry chalk valley, and it's on top of the city's aquifer. That's where we draw our drinking water from. And it has a combined sewer system. So what happens, the landscape here, you can see there are these dips. Even in a dry valley, it's not like a straight curve. You get these little dips in the landscape. So what happens is, obviously, the water runs down and gets pooled and floods around these areas. So you can see here how steep the valley overall is. And then what you get is this before, then you get this flood event, which actually gets into people's gardens, and it could be bad enough to get into their houses. But usually the water is gone within an hour. You don't see it. So in Brighton, most people don't think we flood because it just disappears. Once it clears the topsoil, it goes down the chalk into the aquifer. So what we did is we teamed up. So I'm from the planning department, and at the time, the flood risk manager and I wanted to kind of get some money to try, improving the environment, the overall look of the area, but also introduce some SuDS. We had a number of complaints around this area. And actually further down this mini catchment. So this is the mini catchment. So what we did is we chose an area, or actually the flood risk manager chose an area that would stop the water before it got to the flooded areas. And that created the fact that most people who flooded were involved in the project in the beginning, but the people who were not flooded, but actually had the SuDS in front of their houses, then got engaged further down the line, and that created all sorts of interesting dynamics. So I won't go down, but we wanted most of the things that people had talked about, and also, so this is what it looks like. So we chose this. This is going down the hill. So this is quite, this is the way the water kind of moves. This here is a triangle without any underground services. And then you had phase 2, which is absolutely packed with underground services. We had to break it initially. We were going to do it in one go, but we have to break it in two because this one here cost around 42K. This one about 185 at the time. So this is a while ago. So first lesson, try and avoid underground services and don't be fooled by nice green grassed verges. They can be quite complicated underneath. So it was a long-term period. We put the funding, the bid in 2016, and then we completed in 2022. This is the concept. So the idea was developed by Robert Bray Associates. We had a competition for ideas, and he won that competition. And we had some residents in the panel helping us select the scheme. And this is the concept. So we have the runoff from the road that's then diverted through an inlet to what they call a retention basin with wetland planting. So this is a basin that's got a lining. So in the first phase, we used plastic lining. In the second phase, because of the services, we had to do the traditional lining, which is compacted clay. So apparently any pond in the UK has this sort of lining, and it's more environmentally friendly. So in this first one, the water is cleaned up by the planting and everything, so it doesn't infiltrate into the ground. The cleaner water on top then gets diverted via swale to an infiltration basin, and this one is planted with wildflowers. And we had a number of those coming down until, when the whole system is full, then the excess gets diverted back into the road. So this is the dual basin concept, and it kind of permeates the whole SuDS project. This one is quite flat, and you'll see, I'll show the pictures, whereas phase 2 is very, very steep. So the design varied a little bit. There were some sort of cascading devices that were put there to kind of stop the water. You'll see in the picture. So this is what phase 1 looked like originally, and then this is after the landscaping was done, and this was it on its kind of, it looks like this during the beginning of the spring. And then this is it with water in it. And you can see here how the water gets in, the swale. This is the line basin, and this bit here is the infiltration basin. This is the steep bed, so this is the second one. And again, that shows how what these things look like. And this was, you know, each pond was kind of different, was in different levels. And then you can see how it works. Well, some of them working, and this is the very top level with the retention base that I was talking about. And this is what it looks like. The interesting thing is that because the water goes through the top soil so quickly, during the summer, you get drought and some of the planting gets affected. So that's something that you have to consider as well, because in our case, SuDS won't have water most of the time. And I think phase one, it was in the middle of the pandemic, and the project manager and I was project coordinator for this. We had to borrow some water from residents to water some of the trees because there was a really, really bad drought that particular year. So lessons learned are load, and depending on which phase we're talking about. So in the design phase, I really loved this drawing here. It was one of the first things that came across us. It was our first. We had not even picked up the pen at that point. And we held a series of workshops. And this is a drawing from a resident that told us that which side of the road the runoff was coming down. This was amazing because if you get it on the wrong side of the road, you have to then change levels, and it's really complicated. So this was really, really helpful. And there were all sorts of annotations and things, and you can see here the workshops that we did with residents. We did some training with officers, so we took them to Enfield. Enfield is great. I think they have 300 plus SuDS. And we also did with officers. So we kind of had, and the water companies, you know, all sorts of people, local people that are involved with that. So tap into technical knowledge of all sorts. Everybody has something to contribute. The thing is, this is probably one of the things that affected a lot the project. I was involved from beginning to end. The project manager kind of joined at some point and was until the end. But there were loads and loads of officers changing over time. And every time we have a new officer, you have to make the case, you have to bring on board. It's, you know, just be mindful that things will change and, you know, give yourself time to deal with these things. Yeah, the underground services were a huge, huge learning curve for us because we've got different types of ways of assessing where they were. And we had ground penetration done. We had drawings from the gas and the various utilities. And actually, when it came to the ground and we did all the, you know, inspection holes and everything was out of place. So, you know, go for inspection holes when you kind of do this. And the gas company had a gas governor, and we found 4 valves that they were not aware of. So there, you know, avoid services if you can, but if you can't, SuDS are great to design around. The original design for this was quite different. There were larger, you know, this is the final design, and there were larger basins. But because of the services, you can then kind of accommodate and design the SuDS around them. So there is that as a good thing. Yeah, I said, don't assume that the utilities know what SuDS are. That in our case, the gas people had never seen a SuDS drawing. So that was a lot of conversation and bringing people around the table to explain. That will take quite a lot of time. there is this thing, if you do have to do inspections where you have services, there is this machine that we only learned about halfway through. If we had known this, we would have done our inspection holes using this machine, which is a big vacuum cleaner. And it's amazing how it kind of sucks everything, topsoil, clay, everything. Is quite amazing. So it goes into the truck and they move it. You have to stop traffic and all sorts of stuff. But this is, highway management. The other thing is, in some places, people, when the constructors were doing this, and again, the builders, the contractors had never done SuDS before, but there was good learning curve for them and for us. And you shouldn't really have machines on top of SuDS because that compacts the soil, and then you can't plant anything on top. So there are like little bits everywhere for everyone to learn. Sorry, I was going to say the name of this machine is VACX, if you want to know more about it. This is when we were this is the kind of thing I was talking about. I'm sorry. In terms of the changing seasons and how harsh some of the, can be too much rain, little rain, and whatever. So think about what you might do to safeguard the planting. Interesting thing is this bit here. This guy was the flood risk manager in Brighton Hove at the time, and he created this triangle to make sure that the contractors got the right angle for the basin side. So that was absolutely amazing. It kind of because they had to correct the first basin, they had to correct about a couple of times. And as you know, I think the angle is very important for this sort of thing. So I kind of run out of time. There were lots and lots of people involved in this. There were, keep your politicians on board, very important. So I won't go into this. We did a maintenance plan, but one of the things I would say is that this photograph for me was quite interesting. Is that inside the verge, that's city parks domain, and outside the verge, that's highways domain. And for us to agree a maintenance plan across this line was a very interesting thing. It took us 2 months, but we did in the end. So sorry. So I won't go into that. What I would say is that when we put this in, there were a number, I have another graph, people who flooded. After the SuDS were installed and after 2021, and I've talked to the monitoring officer in flood risk a couple of weeks ago, since then we have had no complaints of anybody flooding. And the records that we have of what people flooded before was quite significant. So I guess that's it.
Thank you so much, Paula and Alice. An absolutely fascinating presentation.